concentrations of dissolved gas and lower concentrations of dissolved organic matter and lower concentrations of, oddly enough, microbial activity, because the substrates, the things they're eating, are lower in concentration. Does that make sense?
Yeah, that does make sense.
Okay.
Can I just ask just one other thing with regard to that? What is the significance of the fact that the microbial numbers doubled over a 24-hour period? I think I understand what you're explaining about the distance, but I don't really understand what you're saying about the time and why that's important.
It just tells you, well, first of all, the fact that the population doubles over 24 hours is a little surprise. I mean, that's fast. That's a fast doubling. Typically, if you were to do an incubation in just Gulf of Mexico surface water, or deep water for that matter, for 24 hours, there would be an inconsequential change in microbial numbers. You could measure low rates of respiration, background rates, if you will, but you certainly wouldn't see a measurable change in numbers of cells over that time scale. The fact that the population, if the population had increased by 10%, I would have been pretty impressed, because that's a substantial growth rate. The fact that it doubled is kind of jaw-dropping. I mean, that's incredible that it doubles. I mean, that's like a culture flask in the lab. That's an experiment that you basically load and dose with carbon and nutrients, and you make them fat and happy, and they have everything they need, and they're just going crazy. That's effectively what a doubling means. It means that you've basically, it's like you've taken this water and put it in the lab and given it everything it needs, and so the population, there's no constraint on growth. I mean, ultimately there obviously is a constraint on growth, but the fact that the population doubles tells you that they're responding very, very rapidly to the conditions in which they're growing.
And you measured that doubling over 24 hours, how far from the wellhead?
I think the station 66 was it was less than 3 kilometers. I'd have to look to tell you the exact distance, but it's certainly within 3 kilometers of the wellhead.
Thanks very much.
Yeah. Jim.
Could I ask a follow-up question on that from the phone?
Yeah, go ahead.
Hi, my name is Jean Bonner. I'm calling from WABE in Atlanta. And just on this doubling, I understand that it's amazing. I guess the question I would have is does it disturb you, because then it suggests obviously all these microbes are going to have to consume oxygen in order to continue to live, and therefore that would contribute to further oxygen depletion?
Well, that's part of it, but like I said, they can't sustain that sort of a rate. Can't be sustained over long periods of time. And in fact, you can think about it this way: if the population is doubling, then the oxygen demand is effectively doubling. But the microorganisms are like they're like many other organisms in that they have concentrations of say oxygen that make them happy and others that make them sad, and eventually the oxygen is going to get to a point where it's below the ability to sustain the community, and that can happen before the oxygen is drawn down to zero. So as you consume more oxygen, the rate is as the oxygen concentration drops, the rate of consumption is going to drop along with it, just because of sort of kinetic concerns. So you can't sustain growth rates like that for long periods of time, simply because the population is going to consume the substrate, and the rates are going to change. Rates of processes like oxygen consumption or methane oxidation are concentration dependent. So as long as you have a high concentration of substrate, you're fine. But once you start pulling those concentrations down substantially, the rates are going to drop too.
Okay, but then potentially, while this is an amazing result, it may not tell us something wider about methane in the plume. Well,
I think it tells us that the population is responding rapidly and dramatically to the gas inputs, and the question then becomes, how long is that sustained, and what are the oxygen concentrations? What do they look like further afield from the wellhead? And as I said before, there just haven't been a lot of measurements made far afield from the wellhead, and making measurements close in at 3 kilometers and seeing high concentrations and interpreting that to mean there is no oxygen problem. I don't think that's a wise way to to make conclusions about oxygen, because you're looking at only a fraction of, you're looking at the front end of the problem, not the tail end. So I don't think it's safe to conclude that it's not safe to conclude there is an oxygen problem either, but it certainly isn't safe to conclude that there is no oxygen problem based on oxygen concentrations that are measured close to the leak site.
Okay, I think I'm just trying to fit this into the context of other things that I've reported based on these conference calls, and obviously, you've expressed a large concern about the amount of methane in the water. But when I try to think about how I'm going to report this, I don't know how to connect it to the wider. You're saying that they're actually responding very well. Well, I could kind of say, oh, well, that's good, and yet I know you've said, well, methane in the water is a problem.
Well, methane in the...
Sorry, I know my question is probably so stupid, but...
No, there is no such thing as a stupid question. It is a bit of a... It's complicated. Lots of methane in the water drives high rates of methane consumption and high rates of oxygen consumption. The problem is, methanotrophic, methane-eating bacteria are not very good competitors for oxygen. And when oxygen concentrations get below about, well, let's just say level A, because it varies with organisms, say, 50 micromoles per liter or thereabouts, they start to slow down. So if they slow down, that methane moves somewhere else and gets oxidized by another group of organisms. The bottom line is that the community is responding rapidly to this dissolved gas influx, and the rapid response means that A, they're either going to draw the oxygen down fast, which we don't know if that's the case, how long can they sustain these rates, or B, they're going to slow down because the oxygen is getting drawn down, which means C, the gas is going to diffuse somewhere else and be oxidized. It doesn't change the fact that methane, the take-home message is that methane drives oxygen consumption, and these organisms in these plumes are responding to the methane. They're growing very rapidly, they're consuming methane, and in the process consuming oxygen. And again, like I've said many, many times, we don't know what the larger scale impact of that is going to be with respect to oxygen depletion and the scale of any water mass that could potentially become oxygen depleted. We just don't know the answer to that because we haven't made enough measurements.
Okay, thank you so much.
Is the lost opportunity in studying the methane hydrates just a matter of there not being a research team that has stepped up, and can anything be done about that? And then are there serious methane emissions into the atmosphere from the oils?
Well, so the question is the lost opportunity because no one was willing to step up to make the measurements, and how much of the methane is going to the atmosphere? I'm going to answer the second one first. Surprisingly, if you look at methane concentrations throughout the water column, the surface waters are supersaturated with methane. There's some flux of methane to the atmosphere, almost certainly, but it's very small relative. It's certainly not what you would necessarily expect there to be. Most of the methane is being trapped in the deep water, and that's not surprising because it's cold and it's at high pressure. So there's a large potential for solution of methane into that water. The first question about a research team wanting to do it, absolutely, there were multiple people that wanted to get out there. I mean, one of our primary goals was to document, the methane concentration fields out there. The issue is just one of scale. One cruise and one group of investigators can only map one little zone of water well, and there have been, so far, to my knowledge, 3 cruises upon which methane concentrations were measured. That was my cruise, John Kessler's cruise, and a cruise that was on one of the Hui ships, I believe the Oceanus, and that was Rich Camilli from Woods Hole had an in situ instrument to measure methane concentrations. In terms of measuring methane consumption, I think that was only done on my cruise and John Kessler's cruise.